So in this case, we are going to consider a typical exam revision, working on our number patterns, the sequences, and series. So having this question, we are given on question number 2, that is 2.1, consider the quadratic sequence. So take note, they have already specified the sequence that you are given, that it's a quadratic. So this is our quadratic sequence, and from there we are given to determine Tn. That is the nth term of the quadratic sequence. As we do understand, on a quadratic, Tn is equal to an squared plus bn plus c. So already we are given, guys, we are told that it's a quadratic. So how can you attempt this question? All right, let us have our question here. So if you are to consider our sequence, that is 72, followed by 100, 120, 132, and so on and so on. So given this, remember, on a quadratic, we are going to determine the first differences, all right? So we're going to have the difference of these two and so on as you consider your terms. Remember, this is your first term, T1, T2, T3, T4. So that's T2 minus T1, the difference 100 minus 72. That was going to give us 28. 120 minus 100, that was going to give us a 20. 132 minus 120, that is a 12. That is the difference. Take note, it's a quadratic. We know that the first difference won't be the same. So you have to determine the second difference, all right? So that is the difference between these terms, 20 minus 28. That is 20 minus 28. Take note, this one minus this one. So that was going to give us minus 8, 12 minus 20. That's minus 8 again. So that is what we have. How are we going to determine the value of A, the value of B, and the value of C? Remember that from our quadratic, 2A is equal to the second difference. So that is the second difference, which is the common difference of the second difference. It is common throughout. So you equate to minus 8 divided by 2 by 2. So meaning to say our A was going to give us a negative 4. Then we move on to another part to determine the value of B. Remember, I said you're going to use the formula 3A plus B is equal to this part of our first difference, first value that you're having on the first difference there, which is what? Which is 28. So I said for you not to have a mistake, just take these terms, all right? This is minus 8, 28, and so on, up to the 72, these ones, all right? So that you don't have confusion. So that is where we are. I talked about these guys on our introduction, so I hope that we are together. Then let's substitute the value of A, which is minus 4. So that's 3 times minus 4 plus B is equal to 28. 3 times minus 4, that's minus 12, plus B, which is equal to 28. So to find the value of B, we have a linear equation. We have to solve for B. So we're going to take the minus 12 to the other side of the equation. It is going to be a positive. Remember, this is a negative, so it's going to be a positive. So B is equal to 40. That is if you add these two. Moving on to the other part, we have to determine the value of C. At this point, we need C. So what are we going to use? I said A plus B plus C is equal to, now you consider the first term that you're given on the original sequence that you're given, which is what? 72. So that's it. So in actual sense, guys, this is what you're going to have, all right? We just take it this way for you not to have challenges. 2A is equal to this. 3A plus B is equal to this value. A plus B plus C is equal to this value, just like that. We have the value of A, the value of B. We calculated these values. So we're going to substitute in place of A. that is minus 4 plus b, which is a 40, plus c, that is equal to 72. Remember, we do not have the substitute for c. That is the value that we need to calculate. So we do not have a substitute for that one. Let us add these two. That's positive 36 plus c is equal to 72. Taking the 36 to the other side, it was going to be negative. So therefore, c is equal to 36. We have the value of A, the value of B, and the value of C. That is, we are going to substitute into our general formula representing our Tn. So therefore, in this case, our Tn was going to be given as An squared. Our A is what? Minus 4. So that's minus 4n squared. Plus Bn, our B is what? 40. So that's plus 40n plus C, and our C in this case, our constant, is 36, just like that. So this is what you're going to have representing Tn, which is the nth term. So questions can be like this. You have to be very, very careful in your simplifications. All right, so we are going to have this nth term to answer any question about this quadratic sequence. So we actually need this Tn to answer any question. Maybe we're gonna need that. So that is Tn. Remember, it is equal to, we obtained minus 4n squared plus 40n plus 36. All right, so that's it. Let's move on to another part. 2.12, a term in a quadratic sequence, 72, 100, 120, which is the same quadratic sequence, this one. All right, so they're saying there is a term in this quadratic sequence is equal to the 12th term, all right, of the sequence of the first differences. All right. Determine the position of this term in the quadratic sequence. So, guys, let us understand the question. They are saying a term in the quadratic sequence, which is the one that we calculated our Tn, meaning to say that is 2.12. I'm just going to write it this part here, 2.12. Tn of the quadratic sequence, which is the one that we obtained here, all right, which is the minus 4n squared, all right, plus 40n plus 36, this one. It is equal to a certain value as it is. We are supposed to equate this to a certain value so that we can formulate a quadratic equation that we are going to solve. But the value now that we are supposed to equate here, we do not know. Like we're supposed to have it like this. This is our Tn. Tn is equal to this value, but we do not know that value. So what is that equivalent for the Tn that we do not know? That is the one they are saying it is equal to the 12th term of the sequence of the first differences. Take note. The sequence of the first differences, remember, this is what we have for the first differences here. When you determine your differences, this is the first, this is the second. So they are saying it is equal to the 12th term of the first differences. If we are to take the first differences, this sequence here, the first difference is what we have. All right, let me remove this part. Remember, for the first differences, our sequence is given as, this is what we have now. We are going to start from that part of 28, 20, 12, like this. What type of a sequence is this? We are talking of an arithmetic. Since the differences that we have here is this minus 8. Remember, we already have the differences. That is one that we got the minus 8. And it's a common difference. This is, we are now considering, guys, this now is a new sequence on its own. It is a new sequence. Forget about what you had before. What type of a sequence is this? That's a linear. Arithmetic, we have got what? The common difference. As we determine the common difference, there we obtained -8. The common difference, if you subtract this, is -8. So we're dealing with what? An arithmetic sequence. A linear pattern that we have. So on an arithmetic, how do you find the nth term, which is Tn? Because they are referring to that nth term. We do understand under an arithmetic, Tn is equal to what? That is A plus n minus 1 times D. All right, so if you've forgotten this, the formula sheet is there. You now be working with the formula sheet, so you can actually have this. This is for a linear Tn. Then if you are dealing with a geometric. So in this case, we are dealing with what? An arithmetic for a linear. That is the formula to represent the nth term, Tn. This is for the nth term. This is the one that we are told here to say, because we need that. But that nth term can be determined because they are saying is equal to the 12th term. So we are given, or we are told that n is what? N is 12. So as we need to determine T12, what is the value for T12? For this new sequence that we have, what is that? Corresponding to T12, all right? Because we are told that the 12th term for n is equal to 12. What is going to be our T12? So you can just substitute, guys, direct. Yes, you can first find Tn, it's up to you, but this one is it's not like a question that is under an arithmetic. It's a question that we are just taking on from a quadratic. So guys, we can just substitute our values direct. Our n, we understand that is 12. So meaning say T12 is equal to, that's for a linear, guys, all right? So A is our first term. For these first differences, what are we having as our first term? That is our A, which is our T1. That's 28 plus n, remember, your n is what? Is 12. So that's 12 minus 1. Then D is the difference, as we had that the difference there, we already calculated. That is the difference of what? -8. So that's a product there. So that is it, guys. T12, just use your calculator there. It was going to be, all right, you can simplify this. 28, this one was going to give us 11 times this, which is -88, and the difference is -60. Well, just use your calculator straightforward. So this is it. The 12th term corresponds to -60. From this arithmetic sequence of the first differences, this is the corresponding value. It corresponds to what? -60. So let's get back to our question so that we understand here, because we are still there. The question is, a term in this arithmetic sequence, which is this one, for our arithmetic sequence, Tn, which is this one, which is the one that we said Tn. That part of the quadratic sequence is equal to the 12th term of the sequence. What is the 12th term? Because they're saying it's equal. Guys, it's an equation that we are going to form between these two because they are equal. The Tn of the quadratic, remember, this is for our quadratic. This part that we are having here is for the quadratic. They're saying it's equal to the 12th term of the second, this one, of the second differences. They are equal. It's an equation that you are forming there. This whole part, you take it as it is. Minus 4n squared plus 40n plus 36 as it is from the quadratic. Equate it to the what? To the 12th term, which is equal to what? Minus 60. This is what we got. The 12th term of the what? First difference is our arithmetic sequence that we formed. We obtained minus 60. So what is it that you have formed by equating these two? It's an equation. So we just need to solve for what? For n. Solve for n. What type of an equation? Quadratic. The highest exponent there is 2. Remember the format of a quadratic equation. Ax squared plus bx plus c is equal to 0. One of the given sides must be equal to 0. So we're going to take this 60 to the other side. All right, so that's minus 4n squared plus 40n. So taking the minus 60 to the other side, we're going to obtain positive 60. That is 36 plus 60. You add those two, which was going to be positive 96. All right, that's equal to 0 like that. So in order for us to determine or to solve for n, we can reduce this equation, guys. Yes, it's a quadratic, and we can see that 4 there, 40, 96. 4 is common, and we can avoid working with a negative. So you can simply divide by negative 4. Let me just do this. We want to remove this negative 4, and it is the highest common factor between these numbers. So you can simply divide each by this negative 4. So this one was going to cancel, and we're going to remain with n squared. Positive 40 and negative 4, that was going to be negative 10n. 96 and minus 4, that's a negative 24, which is equal to 0. Solve this equation by factorization method. Since the coefficient of n squared is 1, we are just going to have 2 brackets with n and n here. Then we consider the constant minus 24. What are the products? 2 factors that you multiply to obtain minus 24. But when you add, you're supposed to obtain negative 10. Which numbers are you going to consider there? Minus 24. 2 numbers. You multiply to obtain minus 24. But when you add, you must have a negative 10. So as you can see, guys, we are talking about 12 and a 2 there in between that. But for us to have a negative, it means one of these must be a negative. So it's either we are going to have minus 12 and 2, or we are going to have 12 and minus 2. Multiply these guys, we are going to obtain minus 24. But which part, when you add, you must have negative 10. So this is the part here. If you add these two, minus 12 plus 2, that's a negative 10. So these are the numbers that you're going to insert here. Minus 12 and 2. So that's minus 12, positive 2. So that is it, guys, for the factorization part. Just use the way that you understand. But at the end, you're going to obtain these 2 brackets. So you can have the value of n. The minus 12 to the other side is going to be a positive 12. The positive 2 to the other side of the equation, it was going to be a negative 2. So n is equal to minus 2. So also solving these equations, guys, make sure that you do have a recap from your grade 11 mathematics, grade 10 mathematics, solving quadratic equations by factorization method, quadratic formula, completing of the square method. So many ways. All right. N represents a certain term, like you're counting to say the first, the second, the fourth, and so on. So n cannot be minus 2. It's going to be only positive. So n cannot be equal to minus 2. So therefore, our n in this case was going to be 12, according to this equation that we have solved. The nth term, the general part of our nth term of the quadratic is equal to the 12th term of what? The sequence that we formed from the first differences, which is an arithmetic sequence. So these two, if they are equal, it's an equation. Form an equation, solve for n, just like that. So this is how these questions can be given as. Just try to revise, work out as many questions as you can. All right, let us consider another typical question that we are given, still working with this sequence. We are given to determine the maximum value of the quadratic sequence. The maximum value on 2.13. The maximum value. Guys, it's a quadratic sequence. It is just like you are given, you see, to determine the maximum value, just guys, use the basics that you understand. If you are into the derivatives, it's up to you. Use that idea that you understand. Let me just remove this part. I just hope we're not gonna need this part that I'm removing, guys, because I have already removed it. All right. So this is it. Working with these terms. Okay, guys, let me do this because you never know. You never know. This is maths, guys. You never know. This part, you might need it. Let me just do it this way. So this is it, the way that I wanted you to understand. Working with the quadratic expression is something that is common to you guys. You have been working with this from your grade 10. All right. Our Tn is given as minus 4n squared plus 40n plus 36, like this. If we are referring to, because we have the idea of a quadratic expression, that part of a quadratic function. If you have got a function, let's say 2x squared, you're actually given something like this. F of x is given as x squared plus 5x plus 6. And there you are being asked to calculate the maximum value. You're asked to calculate the maximum value of this function. How are you going to calculate the maximum value? There are so many ways. You've got that method of using x is equal to minus b over 2a to find the value of x at the maximum value. Then you substitute that value of x into this function to determine the y value. You can obtain the value of x at the turning point by the derivatives, as we do understand that at the turning point where we've got the maximum value, the first derivative is equal to 0. Any of this is supposed to give us the value of x at the turning point for a function. Here we are referring to a quadratic sequence. The pattern, the formation, this part, it's of a quadratic. So it follows the same path of a quadratic. Meaning to say, at the maximum value, at the maximum value, instead of us using x, like what we have, we're dealing with functions, we are going to consider what? N. It is in terms of n. So meaning to say, at the maximum value, n is equal to minus b over 2a. Or at the maximum value, the first derivative of this function that you're given must be equal to 0. So with any of these two, you are going to find the value of n. All right, let's start with this one. If n is equal to minus b over 2a, remember a, this is your b, this is your c. So therefore, n is equal to minus b, which is the coefficient of n. That's minus, then this is a 40 like this, over 2 times a. Our a is negative 4, like this. So we are going to obtain the value of n, which corresponds at the turning point. But in this case, we are referring to what? To the maximum value. So it's the value of n which corresponds for the maximum value. So that was going to give us 5. If n is equal to 5, What is the maximum value? At the maximum value, n is equal to 5. So what is that maximum value? So in this case, the maximum value is going to correspond to what? To T5. When n is equal to 5, that's T5. You substitute 5 in place of what? In place of n. Wherever you see n, you substitute 5. So that was going to be minus 4. In place of n, substitute 5. That's 5 squared. All right. Plus 40 times n. So you're substituting there in place of what? In place of n. All right. Sorry for this. So that is plus 40 times n. Remember, our n is 5. So in place of n, you're going to substitute a 5 plus 36. You're substituting in place of n. Then you can have that maximum value. That is 136. So it's the same as you're calculating T5. So that is how these questions can be given as. So you have to be very, very careful. All right. I also said working with the maximum value, you can also use this concept. Remember, we can use the first derivative. Remember your derivatives. But in this case, it's a function written in terms of t. So it's going to be the first derivative is equal to 0. So you have to differentiate. All right. 2 times minus 4, which is minus 8n. This is plus 40. All right. Which is equal to what? To 0. Solve for n. Minus 8n is equal to 40 to the other side. That's a minus 40 divide by negative 8 by negative 8 both sides. So n was going to give us what? N was going to be 5. So as you can see, at this value, you substitute into this Tn. You're going to obtain the same value of 136, just like that. So it depends, guys. It is you and your understanding that matters. You can use any part. That's for the maximum value. All right. Considering the other part, we are given this sequence. Determine the maximum value of the sequence. Minus 23, 5, 25, 37. All right. If we are to consider this sequence, guys, all right, I want us to consider something here so that we can see properly here. If we are to consider this part, the first part that we can see is we are going to have the first term, which is negative 23. Then we want to figure out, like, what type of a sequence is that one? What type of a sequence is this one? Is it a linear or what? Okay. Let's take this part. Minus 23, 5, 25, 37. Let's just try to figure out because it is different from what we had here. But we want to figure out what is happening here. The difference, all right, we know your differences, guys, as usual. 5 minus 23. So it's 5 minus, so this is minus 23. So it's 5 minus 23. So this was going to give us 28. 25 minus 5, that's a 20. 37 minus 25, that's a 12. Then we determine the difference again because we can see that these differences are not the same. So let's determine the second one and see. So we're going to have 20 minus 28, that is minus 8. 12 minus 20, that is minus 8. We cannot, noticing this, we can see that there's a difference, a second difference of minus 8. From this one, the second difference that we had, it was also minus 8. Okay? Let us go back to this other part. If we go back here, we can see that we've got 28, 20, 12. It means there's something common about this quadratic. it is the same sequence as before. This sequence that we are seeing here. Remember, it is having the numbers 72, 100, this and that. It simply shows us it was a continuation before this sequence there that we had before. It was the same. It's from the same sequence. That is what it means, guys. It's from the same sequence. So if it is from the same sequence, guys, are we going to determine again that quadratic? No. We understand that if it is the same sequence as before, this is it, guys. Let me finish up here. If it is the same sequence as before, therefore it follows that its maximum value is at the same position as what we had before. All right. It's only that I erased that one. But remember, from this one, from here, from this one, when we determined the maximum value of the quadratic, the maximum value, when we calculated, it was at n is equal to 5. Then we substituted that value to find T5, which gave us 136, something like that. But it was at n is equal to 5, which means it was the 50 value. That is at the 50 value. So if it has the same concept, the same sequence, if it is the same sequence, therefore it means the maximum value of this sequence is at n is equal to 5. Meaning to say our maximum value is T5. That is what it means. Our maximum value, just like here, which was T5. Also here, our maximum value corresponds to T5, which is the 50th term. So are we going to form the quadratic and then find T5? No. We just have to go, because this is the first one, the second one, the third one, the fourth one. What is the 50th term here? It is something that you can actually notice. You determine that. That is what it means. Just like that. So if you have an understanding of this, guys, you're not going to go through all this. You know, okay, this is the same sequence. So if it is the same sequence, I just have to use what? T5, the 50th one. So what is the 50th term here? That was our question. How do you find this 50th term here of this sequence? All right. Remember, guys, there's a difference of -8. So if we add -8 here, we're going to obtain a 4. Then we do the same thing. Remember, how do you obtain this, guys? You'll be adding 25 plus 12, which is 37. So it means 37 plus 4 is equal to what? 37 plus 4 is equal to 41. That's our 50th term. We just like we've got T1, T2, T3, T4, T5. Our T5 corresponds to what? To 41. So therefore, our maximum value was going to be 41. That's our maximum value, 41. So guys, you see, it's 1 mark. Is the understanding there is important. If you have that deeper understanding, you won't go through all this process. But this is for the sake of us understanding. That's the importance of revision. All right, let's consider another one. 2.2, you are given to consider the sequence, and this sequence you are given -11 to sine 3x 15. We are now into trigonometry. Whilst you are working with number pattern sequence there, but look, the trig is part of it. So they are saying, determine the values of x in the interval from 0 to 90, for which the sequence will be arithmetic. If it is going to be arithmetic, what is the understanding? If truly it is an arithmetic, we are given -11. This is 2 sine 3x. This is 15. If truly this is an arithmetic, we understand that there is supposed to be a common difference, which is the same. T2 minus T1, T3 minus T2, and so on and so on. So we use the concept there. This is our T1, our T2, and our T3. The difference is the one that we need, the common difference. T2 minus T1. That is 2 sine 3x minus T1, which is minus 11. That is what we have there. It is supposed to be equal to T3 minus T2. That's 15 minus 2 sine 3x. This is what we have. All right, so that's 2 sine 3x minus minus, guys. That's a positive, which is positive 11 is equal to 15 minus 2 sine 3x. All right, combining these, we can see that these are like terms, sine 3x, sine 3x. So we're going to take the minus 2 to the other side so that it is going to be a positive. So that's 2 plus 2, which is 4. Sine 3x is equal to, take the 11 to the other side, it was going to be minus 11. So 15 minus 11, that's a 4. So that's it, guys. Simply divide by 4 to remove this 4 multiplying. That is the sine of 3x is equal to what? Is equal to 1. So if the sine of 3x is equal to 1, remember, guys, we are given an interval from 0 to 90 degrees. From 0 to 90 degrees, guys, this is your basics of your grade 11 mathematics. You just have to find arc sine of this. There we do not need to gonna work with the reference angle, this and that. Guys, there's a 90 from 0 to 90 degrees. You use those ones if you're given maybe from 0 to 360 or 0 to 18. Not from 0 to 90. So we just need arc sine of 1 from your calculator. Arc sine of 1 is 90 degrees. So the angle, which is 3x, is equal to arc sine of 1, which is 90 degrees. Divide by 3, divide by 3. So that's our x. So our x was going to be 30 degrees. That's within this interval. That is the value of x satisfying our equation. Like I said, guys, from 0 to 90, there is no need for us to make any special adjustments. We just need to work with this. So, guys, that is it. You need to revise as many questions because you see they can give you a condition which relates to trigonometry there. They know that you have these basics from what? Your grade 11 mathematics. This is the basics of your grade 11. So do revise everything as you had it from your grade 11 mathematics. So that's it, guys. Till we meet again.